This is John Black, Super Chemist. This is not an instructional video. It is just a vlog showing a video account of some chemistry experiments I have done or am learning about. I do not go over all safety concerns, so if you repeat anything in the video, you do it at your own risk. This is part 2 of sodium ethyl sulfate synthesis. Now we want to reflux it at 120. I want you to look over here. Here's the boiling point of the sulfuric acid, ethanol, and where we want to be. And I don't look these up, so they might not be perfect boiling points. But if you have a mixture in the pot of these two things, right? Like we said, 80 and 90 milliliters. That boils at 145, right? That would be up here. So if you want to lower the boiling point of the pot, you add in the lower boiling point thing, the ethanol. If you wanted to raise the boiling point of the pot, you'd add more sulfuric acid in it. So all you have to do, if you're here with 80 and 90, obviously you'd add more ethanol so it gets the boiling point down to 120. That's where you want to reflux it at. And what we're going to do that was for diethyl ether, ethyl bisulfate, that's wrong, that should be an A. Bisulfate, we want to boil it at 120. And keep in mind, this would be if it was anhydrous. So mine isn't anhydrous. It would be 80 milliliters of sulfuric acid and 160 milliliters of ethanol. Now keep in mind, that's nice and easy to do. You just double it. 80 and 160, right? So if you have a milliliter of this, 2 of that. If you have 10 of this, then it's 20 of that. 100 of this, 200 of that, etc. You just double it. Now, since I'm not using totally anhydrous chemicals, I'm going to have to guess. This is a starting point. If I get it up to 125 Celsius and it's not boiling, that means I need to add some ethanol in so I can lower the boiling point. If it's boiling and it's not 120 C yet, that means I need to add just a little bit more sulfuric acid to get the boiling temperature up to 120, 125. Now before we get into how much I used, let me go over a couple things. Here's the equation again. Keep in mind, this is an equilibrium equation. Okay, so you can only make so much of this product before the equilibrium will stop it. Okay, how do you push the equilibrium to the right, over to here where you want it? One way is by having excess of one of these things over here. It doesn't have to be ethanol, it can be sulfuric acid, but we already have the ratio of sulfuric acid to ethanol as a 1:2 ratio in milliliters. So that's set. There's nothing we can do about it. But that does give you an excess of ethanol, a lot of excess. All right. So that will help push the equilibrium to the right. Another way to push it to the right, instead of adding an excess of one of these two things, we take out one of these two things that it's made. Okay, as soon as it's made, we got to get it out of there. It doesn't have to be water, it can be this. But water would probably be easier. And the reason I'm not going to do it, but what you could do is put this in a soxhlet apparatus and reflux it so that the pot is refluxed through magnesium sulfate that's anhydrous. Then when you're done refluxing, pour a little bit more ethanol through the magnesium sulfate, to wash out any product that's in there. Alright, I'm sitting here editing this video that I'm making, and I'm realizing a mistake about the magnesium sulfate. Because you're using water, because you're making water during this reaction, you'll have some water in the mix. And plus I didn't use totally anhydrous ethanol, so there's already water in there. My whole point is if you use magnesium sulfate, it might dissolve inside your pot, as you're putting the pot liquid through the magnesium sulfate to wash out the water is going to dissolve some of the magnesium sulfate. So you need something in there like molecular sieves, although the acid might destroy the sieves. So you need something that's not going to react or dissolve in the pot. You know what I mean? And this would work. But magnesium sulfate is not a good idea. It's just going to dissolve inside the water. I want you to look. This is a regular refluxing. You know, you got your round bottom flask and you have a water cooled condenser. You boil your stuff and you can't escape because it's so cold up here. It condenses back down into the pot. This is basically the way a soxhlet reflux apparatus is. Your pot boils, it goes up this little tube, and then it goes up into a condenser. All right. When it condenses down, it can't escape because it's too cold. So it condenses and it drips down into this little vat where I have these brown dots. Those brown dots would represent the magnesium sulfate. Then you have some cotton or whatever down here, or you have a filter there so that none of this drops down into your pot. That way the stuff refluxes off with the water, right? The water condenses down. As it goes through the magnesium sulfate would soak it up, right? It would incorporate it into its crystalline lattice. But the rest of the product and the other solvent would drop back down into the pot. Then when you got done, you got still some stuff in here that's product. You just get some ethanol and pour it in there so that it, forced it down into the pot. That way you could have the equilibrium pushed very much over to the right. You'd have a very, very good yield. Okay. Now, remember, it was a 2-to-1 ratio. You wanted twice as much ethanol as you have sulfuric acid in volume. So what am I doing? I have sulfuric acid. I'm guessing because I'm not doing anything special to it. I'm just using it right out of the bottle. We're going to guess and say it's 95%. All right. So I think it was 54 milliliters was a mole or something like that. But if you divide it by 0.95 or whatever, you get 56 milliliters out of the bottle to get 1 mole of sulfuric acid. So I times that by 2, so I want to put 2 moles in. That's 112 milliliters. Okay, so that's how I picked my sulfuric acid. Now the ethanol, and the reason why I did that is because I want it to be 2 moles, so it's easy to figure out my yield and stuff like that. Now I wanted to add 2 moles of sulfuric acid because that was the limiting reagent, and it would be easy to figure out my yield. I forgot to, I added in some sulfuric acid so I can raise the boiling point of the reflux. And I didn't really measure how much. It was probably about a half a mole, maybe 28 milliliters. But I didn't measure it. So there goes, knowing an exact yield. But still, we're going to carry on and go from here. The ethanol was picked based on what this is. This is 112 milliliters. Remember, we wanted the ethanol to be twice as much volume. So that's 112 times 2 is 224 milliliters. Keep in mind, these are supposed to be anhydrous. If you have water in the pot at the get-go, you've already pushed the equilibrium to the left. You know what I mean? You don't want water. I'm putting water in. All these ratios, everything is based on me not having water. And I'm not going to do that because, I want to see what happens, how much of a loss I get just from doing it without doing anything to the sulfuric acid and only distilling the ethanol, and that's it. Just distill it. Don't dry it up better than an azeotrope. Let's see what happens. You know what I mean? So here's our ethyl bisulfate, and during the refluxing, it turned from clear to yellow, kind of like urine, to this orange color, this orange-brown color. And now we need to make it into sodium ethyl sulfate. Alright, so we took our sulfuric acid, we made it into ethyl sulfate, or ethyl bisulfate, which is a ester on this side, but since it's diprotic, it's an acid on this side still. And what we need to do is make this side into a salt, so it's sodium ethyl sulfate. This side's a salt, this side's an ester. Now these are all acid-base reactions here. The easiest way to do it would be to use sodium hydroxide or any sodium base, sodium carbonate, sodium oxide. And if you take the ethyl part out, sodium hydroxide and sulfuric acid is going to make a sodium bisulfate, but instead of it being a bisulfate, there's an ethyl group there. See how it's the same? It's just an acid-base reaction. You're going to make a salt water. Here's your salt. Here's your water. Now the only problem with that, okay, is you have sulfuric acid still in the mix, right? And if you do this with sodium hydroxide or carbonate or whatever, bicarbonate, sodium oxide, whatever it is, whatever base, you're going to make some sodium, bisulfate over here, okay? And sodium bisulfate, sodium sulfate, all that stuff is soluble along with your product. They're both soluble. That's not a good thing. So what you need to do is use a calcium base. And it doesn't have to be a hydroxide. Actually, mine is probably half hydroxide and half carbonate because it's been sitting there so long. But you can use any even calcium oxide, just because it's just an acid base. You a bisulfate and hydroxide reaction. This is the equation for it. This way you make calcium diethyl sulfate and 2 waters. And the nice thing about it, you might say, well, why do you do that? Because this is soluble also. Both of these are soluble. But your impurity, the sulfuric acid that you want to get rid of, whenever it reacts with calcium hydroxide or calcium carbonate or oxide, it's going to make calcium sulfate, which is insoluble. So this will stay in solution, right? Your product, or what's going to become your product. And this will get rid of the sulfuric acid because this will precip out and you can filter it. You're just going to keep adding this calcium hydroxide or whatever base you choose until you have a pH of 7. You just want to neutralize the acid. Once this acid is neutralized, it's all this. Then there's no more hydrogens. But every one of these reactions is just an acid-base reaction making salt water. You can see you make more water here using the calcium than you do make with this sodium. So anyways, once you do that, once we do that, we will have calcium. We don't want the calcium salt of ethyl sulfate. We want the sodium one. But we got rid of all the impurities. The only impurity that should be in there now is ethanol. And that's a liquid, so it will evaporate in the end. So how much calcium hydroxide am I going to use? Well, if I have a 50% yield, that means I started out with 2 moles of sulfuric acid and 1 mole reacted with this to make 1 mole of this, and you have 1 mole left over because it didn't react, right? So you have a 1 mole of each. It takes 1 mole calcium hydroxide to 1 mole of that. It takes a half a mole for this, and then I added in about a half a mole of sulfuric acid. So there's another half mole. So if I have a 50% yield, and this is just I'm just guessing, or this isn't exact science here. That's 2 moles. I'd need 2 moles if I have a 50% yield, somewhere around there. If I have a 100% yield, that means I have no sulfuric acid left. I only have 1 mole of this that I made. Or no, I have 2 moles of this that I made, but you only need half of as much calcium hydroxide, so I need 1 mole. I put a half a mole of sulfuric acid in extra, so there's a half mole for that. So that's 1.5 moles. So I'm guessing somewhere between 1.5 to 2 moles, and this is just a starting. I want to put enough in that it's a pH of 7. Now keep in mind, I'm taking this to a pH of 7, and then when I change it into sodium ethyl sulfate, I will use I will take the pH up to a 14. Now, the way you're supposed to do it really is to probably take the pH up to 10 right now. Don't miss part 3. And you all have a great day, and always remember, science is great.